I'm Prasanth Vuppuluri. I'm working as a product manager with Deloitte Consulting. My area of expertise or in day-to-day life, I deal more and research more around the public benefit systems. That is the U.S. public assistance benefits. That's what the government gives. The SNAP, food stamps, the TANF benefits, and the Medicaid that come with from the government. I deal across with those systems. So today our talk is on open analytics in action, powering real-time public benefit systems with open source. So we're going to deep dive into how open source technologies and transforming the public benefit delivery through scalable, transparent, and equitable systems. So let's get into the topic. So today we are going to discuss about the challenge that we have and how are we solving it, the architecture of it, the core components, security and compliance, operational excellence, and the real world impact. So the challenge is understanding the scale and complexity of modern public benefit systems. And the architecture, exploring the open source technology stack, powering real-time verification, and the core components are breaking down event streaming, orchestration, analytics layers. And the most important, security and compliance, we are dealing with a public benefit assistance. So it's managing governance in high trust government environments. Operational excellence, DevOps practices for maintaining visibility and reliability, and the real world impact. So, the lessons learned from public deployments at scale. Uh, we're going to go through all this topic one by one. So primarily we're talking about the electronic income verifications. So it's not as simple as it looks. It deals with 850K plus daily verifications every day and connected to the 40K plus 40 plus data sources. And it has to be up 99.9% of the times. So these verifications are real-time income checks processed every single day to support benefit eligibility. And the data sources are these are the integrated systems from federal agencies, state databases, and third-party providers that give the income verification data. And this is 99.9% of the times, it's mission critical availability, ensuring citizens receive timely access to the benefits. So electronic income verification systems primarily is a backbone of modern public assistance. It touches millions of lives while making the highest standards of reliability and accuracy. So why open source for public infrastructure? So we have a traditional approach challenges and the advantages of open source. So traditional approach challenges include vendor lock-in limits the flexibility and increases long-term costs. So proprietary systems lack transparency for public accountability. Limited customization, as we all know, we have a unique government needs and they change time to time with new orders, new bills coming up, and it will be limited and difficult to audit security and compliance measures. When we switch to the open source, it's a community-driven innovation, accelerates feature development, full transparency enables public trust and oversight, cost-effective scaling without per seat licensing fees, and this is the primary thing everywhere. The license fees increasing for the traditional or the uh, commercial systems, and security through public scrutiny and rapid patching. So these are all some advantages of open sources. And let's get into the technology and how we implement or apply the open technology to the public benefit systems. So the technology stack comes like this. It's event streaming, we need orchestration, analytics layer, and machine learning and detection. So in event streaming, we have Apache Kafka that handles the real-time data ingestion from multiple sources with guaranteed delivery. Orchestration, Apache Airflow manages complex data pipelines and scheduling across systems. And for analytics layer, we have Apache Superset and DuckDB that fast queries and interactive visualizations. And for machine learning and detection, scikit-learn and Hugging Face enable fraud detection and pattern recognition. And uh, in general, fraud is one of the biggest things systems have to deal with, because we see uh, fraud often in the systems. And Apache Kafka is a nervous system. So Kafka serves as a central nervous system, connecting 40 plus data sources into a unified real-time verification platform that scales horizontally as demand power. So today it's sometimes it's 40 plus, it can increase to 50 plus based on the need, and it's a ever-changing thing. So Apache Kafka gives the high throughput injection, process millions of verification requests daily with sub-second latency, ensuring citizens receive immediate responses during benefit applications. So all we are trying to do is, the first point is, it's like there is no stopping in between. So people receive verifications regularly, and benefits should be processed without any breaks to them. Uh, and fault tolerance design, distributed architecture with automatic replication, it guarantees the zero data loss, even during the infrastructure failures and maintenance windows. So during these windows, the Apache Kafka helps us hold the requests and responses, but the data will not be lost once the system comes up. Event sourcing, uh, complete audit trail of every verification event, enables compliance reporting, distribute resolution, and system debugging. That's how the Apache Kafka works as a nervous system. And the next important thing is complex data workflows. How do we orchestrate the complex data workflows? So we have Apache Airflow. It powers the pipeline management. So orchestration layer is mainly to ensure the data freshness while managing the resources efficiently across cloud and on-premise infrastructure. And as we all know, the benefit verification system, it is about coordinating with hundreds of dependent tasks across multiple systems. It flows from one system to other system. Sometimes it brings the data from multiple systems together by combining the data. Orchestrating is the most important thing that helps the data workflows. So one is the DAG-based workflows that visually represent dependencies between data transformations, automated retry logics that handle transient failures from external APIs, dynamic scheduling adjusts processing based on system load and priorities, and we have a monitoring dashboards that provide the real-time visibility into the pipeline health. Moving next, transforming data into decisive actions. So we have Apache Superset that empowers the self-service BI, and DuckDB integration that accelerates the insights. So just some explanation about it. So Apache Superset is an intuitive platform that puts the powerful business intelligence directly into the hands of program managers. So what it means is, the program managers, though they are not aware of the technicalities of the system sometimes, they can effortlessly craft custom dashboard, dissect complex verification trends, pinpoint into the operational bottlenecks without extensive IT support. They can do things on their own. It provides the customized drag and drop options, generate options, filters, everything. So, it's like a self-service business intelligence tool. And DuckDB integration, it's about the insights. So integrating with DuckDB provides an in-process analytical database capable of executing sub-second queries across billions of records. Uh, it's super speed. It's a sophisticated, it can generate a sophisticated ad hoc analysis, just not practical, but pivotal for policy researchers, auditors. They want some immediate answers. They want to see some immediate insights. DuckDB integration gives all those quick and fast support. MLPod fraud detection. So as I said, fraud is one of the key things that you know crawl in and may cause to lose the public funds sometimes if it is not handled properly. So what ML does is, it's a pattern recognition. So we have a scikit-learn models that identify anomalous application patterns by learning from historical verification data. They flag the unusual behaviors. and they see this scan each and every application and you know uh, flag all the unrealistic or unusual behaviors for the human validation. And as we said, it doesn't replace the human judgment totally, but it augments investigators by surfacing the highest risk cases for manual review. It protects the program integrity, and it also maintains the dignity of the applications. So ML, as we always say, that it doesn't replace the humans completely, but it gives us all required data so that it is available for a human review. And NLP document analysis. So Hugging Face transformers extract and validate information from uploaded documents, detecting inconsistencies between the stated income, supporting evidence, and also they flag all the inconsistencies that will help again for the review and identify any fraud. As we all know, it's continuous. Learning is one of the key things of ML. So models retrain automatically on the labeled cases, improving detection accuracy while reducing the false positives that burden legitimate applicants. Moving next. This is about building modular data pipelines. How do we build modular data pipelines here? So one is microservices architecture and standardized APIs, container-based deployment, and automated testing. So talking about the microservices architecture, each data source integration runs as an independent service, enabling teams to deploy updates without system-wide downtime. So we categorize into as smallest service as possible, and each of them works on its own. If we have issue with one, uh, we need not disturb the entire system, but we'll just uh, deal with one system and deploy it separately and test it separately. So that gives a cleaner modular approach. Standardized APIs. So these are all the common interfaces between components, allow swapping implementations. So for example, replace a database or replace a ML model without rewriting the downstream consumers. So this will help in dealing the things in a modular basis. Container-based deployment. Docker containers ensure consistency across development, testing, and production environments, eliminating works on my machine problems. So this is always a common problem that we all see. It works in one environment, it doesn't work in another environment. Every IT employee can relate to this, I know. Uh, so Docker helps to solve such kind of consistency issues, and it will be consistent across all the environments. Automated testing. So comprehensive test suites validate each module independently and in integration, catching bugs before they impact citizen services. So automated testing is one of the key things here that we are talking. And while testing each module independently. And governance and compliance in open environment. So really, as we say, we're dealing with a public benefits, which is a very public data and sensitive data, or every data here is sensitive. On top of that, there are certain rules and the regulations that systems have to follow when dealing on the public benefits. So there is a misconception that if it is an open source, it's not secure, but that doesn't mean it's less secure. Transparent code enables the faster vulnerability detection and remediation compared to proprietary alternatives. It is one such thing. Since it's all open, everything is open. It is faster. It has a, I mean, it can help in faster vulnerability detection and remediation when compared to a few tools that are not available openly. Let's go to the regulatory requirements and how our open source solutions deal with it. So GDPR, it's for data subject rights and cross-border transfers. HIPAA, and it's when handling the health-related benefit information, and federal security standards like FedRAMP and FISMA. These are all the Fed security standards. On top of that, for each state, there are state privacy laws that vary, notification requirements, and how open source solutions deal with it. So it safeguards sensitive data with robust encryption at rest and and in transit built on proven community weighted libraries. And it empowers uh, secure authorized access. So we can do always a role based controls and centralized audit logging. So access will be secured, and uh, only authorized people will be given the required access. And it gains the full transparency into how PII data, its personally identifiable information, flows through the systems with comprehensive data lineage tracking. So it streamlined compliance and dramatically reduced manual effort by automating generation of all required documentation and reports. So what we are saying here is just because it's open source, it's not less secure. It has all the features that can follow the federal and state regulations, and it can align to that. DevOps. So DevOps excellence for high trust systems. So the features like infrastructure as a code, Grafana visualization, GitOps workflows, Prometheus monitoring help us as a high trust systems. So we have Terraform templates. Grafana visualization gives us real-time dashboards. GitOps workflows, uh, helps in the version control with peer review, and it creates an audit trail of what is changed, when is changed to look back. And of course, the Prometheus monitoring, the time series metrics capture system health and alerting operators to anomalies before they impact the service delivery. And these systems we're talking about, it maintains the high visibility and auditability, so that if you want to trace back what happened and check back the history, everything is tracked and logged. So we're talking about a comprehensive logging, distributed tracing, and performance profiling. So helps us monitor the visibility and auditability. And the most important thing, real world impact and the lessons learned. So the processing speed, moving to Kafka based streaming, this is a real time testimonial or the lessons learned from the past. So moving to Kafka based streaming reduced average verification time from 4 hours to under 2 seconds dramatically, improving applicant experience and reducing call center volume. And for the cost efficiency, there are certain BI tools. So replacing proprietary BI tools with Superset has saved 2.3 million approximately in licensing fee, while giving analysts more powerful exploration and capabilities. Fraud detection, ML models detected 47 million in potentially fraudulent applications in the first year, with false positive rate under 3%. This is a testimonial from X company who does this public benefit systems, that said, it's based on their prior models. It has brought down the false positive rate under 3%, and it detected 47 million potential fraud. So this, as we say, success requires more than a technology. It demands organizational commitment to open practices, investment in staff training, and willingness to contribute improvements back to the community. And the key takeaways, building the future of civic technology. So open source enables the scalable, transparent public infra. Modern data stacks handle massive scale with high reliability. Security and compliance are achievable in open technology. DevOps practices ensure operational excellence in production. Real-world deployments prove enterprise readiness for government. So the future of digital public services depends on practitioners like you, me, all of us contributing to and adopting open analytics infrastructure.